Thermoplastic polyurethane, commonly known as TPU, is a type of plastic that you most likely interact with every day. It's used in phone cases, athletic shoes, waterproof fabrics, automobile interiors, and those are only some of its thousands of uses. Because of its wide range of applications, the TPU industry is massive. Globally, 550,000 metric tons of TPU are used every year. Despite its ubiquitous presence in our daily lives, there is no effective recycling method that exists for TPU. The most common approach is physical recycling, which takes discarded TPU, cuts it into small pieces, and then thermally fuses and extrudes the pellets to generate new TPU. However, this process drastically reduces the quality and usability of the plastic, especially after multiple rounds of recycling. Because of the inaccessibility and ineffectiveness of physical TPU recycling, most of these products end up in landfills, oceans, and the environment at the end of their life cycle, where they permanently embed themselves into ecosystems by degrading into microplastics. My research with the Mascaro Center for Sustainable Innovation this summer aims to tackle this issue by investigating an alternative recycling method, chemical recycling. We are aiming to develop a simple, scalable procedure for recycling post-production and end-of-life TPU waste, which can be easily implemented at the industrial level. Chemical recycling, as opposed to physical recycling, uses principles from chemistry and engineering to take advantage of a material's atomic structure and reactivity. It breaks unwanted materials down into their molecular building blocks so that they can be used to generate new materials. So, how does this work with TPU? TPU is a block copolymer, meaning that the TPU chain is comprised of linear alternating segments, one of which is rigid and the other of which is flexible. Through a series of chemical reactions, we can separate and isolate the hard and soft components of these chains, producing the reactants necessary to generate new, recycled TPU with physical properties comparable to its virgin counterpart. Not only does this keep TPU out of landfills, but it also lays the foundation for a circular economy model wherein all waste can be directly used to generate new products. The widespread use of this polymer, combined with the current global plastic pollution crisis, means that this project has the potential to be a much-needed strategy for simultaneously minimizing and repurposing TPU waste. And in doing so, we may come one step closer to remedying the planet's plastic problem.